Hi, welcome to session 10. Okay, so we've got our normal recap. We have a particularly tricky one here. So the other 4 questions you should be feeling fairly comfortable with, certainly these ones here. This is really your circle theorem question. That's the one that we want you to do well on. This one is really just about giving you some exposure to prove type questions. Like I've said before, I really want to keep everything in the one unit. It'd be silly to have to look at another course to learn this detail. It is tough. It's at the top end of the GCSE. When it comes to that one, obviously I want you to give it a go. Just literally, what am I looking at? What do I know? How can I apply it? Mark things on. Just remember that when you're proving, you're staying in algebra. The algebra proves it. And really just give it your best shot and don't worry about it. Honestly, if you cannot access that, it is not the end of the world at all, because our ultimate goal in this course is that we can apply those circle theorems and work our way around these types of questions. All right, so hit pause and press play when you're ready. Okay, here are the answers. So let's get that so you can see everything. There we go. Obviously, I've highlighted the that one. It might have been a bit tricky because we'll go through that one. Okay, so hit pause and just have a really good look at all of the information here and make sure that you're happy with the steps that you've done. Okay. All right. Okay, so we are going to go straight into this semicircle question. I'm going to just rub out this side here so we've got some space to work. Now, when I look at this question, okay, I can see I've got my diameter, which means that this point up here, I'm going to mark it in red, I think. I'm just trying to sort out my red. There it is. So this angle up here, we know is 90 degrees, okay, because of the diameter tangent rule. But we're not, we're actually proving that rule with this type of question. We're not actually using that rule, okay? What I know when I look at this is that either side of the center point are radii, okay? So each radius is equal in length. But of course, this line here is also a radius. So when I mark that on, you can now see that I've got 2 triangles that must be isosceles because they are made up with the radii there in the diagram. All right, so let's start marking on what that now means. If this is x here, this must be x here. So let's pop that on. So that's x. And if this is y here, this must be y here. So we'll pop that on. Okay. Now I don't have any numbers. The 90 is the goal, really. I know it from my theorem, but I can't use it because I'm proving. So proving isn't using a fact someone else has given to me. It's showing and demonstrating that I can do it from scratch. Okay, we're going to have a quick look at it kind of transposed out, if you like. So we've got this line and this line going off, okay? And we've got an angle and an angle. I'm looking at this angle here, which is this angle here. Okay, now I've got an isosceles triangle. The triangle has to add up to 180. If I take off the 2x, whatever that number is, if I take it off, it will give me this angle here, won't it? And this angle here, and we'll use our little highlighter, which is this angle here, is working in exactly the same way. It's just a different letter. That angle is 180, take away whatever 2y is. Now together, I can see that those two angles sit side by side on a straight line. So I've got 180 minus 2x plus 180 minus 2y equaling 180. So let's tidy that up a little bit. 180 plus 180 is 360. I've got my minus 2x minus 2y equaling 180. Now, what I'm going to do, I'm just going to make this a little bit smaller so I've got some room and we can keep everything close together. What I'm going to do now is I'm going to bring the numbers together to one side and I'm going to move all the letters to the other. So my letters, which are my minus 2y minus 2x, is going over here, and my 180 is going over here. And when I do that, I end up with 360 take 180. The minus 2x is going to land as positive 2x, and the minus 2y is going to land as positive 2y. My next step is to do 360 take away 180, which is 180. And then on this side, I want to isolate the x and the y. So I'm going to factorize the 2 out. Once I've done that, it means I can actually move the 2 to the other side, which really brings that x and y down by itself. So I'm going to divide that by 2. And again, I'm going to just make that a little bit smaller so I can squeeze the rest of it on. Here we go. When I do that, I get 90 on that side, and then I get x plus y on that side. And that's exactly what they wanted me to do. They wanted me to prove that ABC, which is this angle here, x plus y is equal to 90. And we've done exactly that. X plus y is equal to 90. So with a question like that, when you hear that word prove, you're kind of staying in algebra. You're staying in algebra all the way. So it's really having that confidence to try things. And at this level, without a lot of experience with doing this kind of thing, this is tough. And I appreciate it's tough, but it seems silly not to be at least showing you how this topic can evolve and be made harder. So when we're working numerically with angles that are given to us, we're working at around a grade 6. This type of thing's taking it right up to grade 8 straight away. So like I say, if you're getting some of this, you are doing really, really well. If you're getting it, well, that's amazing and really, really well done. But don't let this put you off. Prove is always going to be a tricky, tricky question. All right, let's get into, resize this page. Let's get into today's session, which is similarity. Okay, similarity is something that you should already be aware of, especially when it comes to length. So, for example, if I gave you this triangle, let's say 3, 4, 5, and I gave you 8 on this and told you they were similar, and this is an absolute key word, they will use the word similar, and this work is what that word needs to trigger, okay? So similar is incredibly important. When you read it, everything we're doing in this session links just to that one single word, okay? So when something's is similar, it's basically been enlarged. So there's a scale factor involved in the problem. So I've obviously written something really nice and simple so that you can see that the small triangle turns into the big triangle by multiplying by 2. This has a scale factor of 2. Okay, and it wouldn't matter what numbers I had there, it would be the same kind of approach. So let's just clean all these numbers up and give us a new set of numbers, just so we're absolutely sure. So if I put 3.2 on this edge and 19.62 on that edge, there's very little I can do. I haven't got the right pairing. So that's another really important thing for us to know about similarity. I've got to pair a similar edge to a similar edge. And this obviously
is the base of the triangle, and this is obviously the horizontal. There's nothing the same about those edges, so they don't pair. Can't use those numbers together to find a scale factor. If I have that here, it would work. If I had that there, it would work. So we might as well leave it there now. So I always approach this, no matter how complicated the question seems, I always approach it the same way. It's always the smaller shape that I am given times by the scale factor, and it will equal the biggest, okay? And that's kind of my go-to standard approach, no matter what the question is. Here, I've got that the smaller is 3.2. I don't know my scale factor, but I know that it's going to give me 19.62. If I want to know what the scale factor is, I'm going to bring that times 3.2. It will land as divide 3.2. And then I can work out that the scale factor is 6. Okay, nice approach that we would use every time. Okay, so let's do one more. Let's say I've got 1.8 on here and 10 on here. Again, it's the, to write the wrong thing then. It's the smallest times the scale factor equaling the biggest. So 1.8 times a scale factor I don't know will equal 10. I'll divide through by my 1.8. My scale factor is now equal to 5.5 recurring. Now, if I've got 5.5 recurring, it's going to look like that, and I'm going to be very, very tempted to round that so that I can carry on with my problem. We must never round, never round, no matter what area of maths you're working in, until the very end. So I can't round, which means the actual fraction that calculator gave me, which was 50/9, that's the number that I would use in my calculations because it's accurate. It's a perfect number. I haven't lost any of it. It's the full, complete number. So sometimes you might find yourself working on a problem where, although you kind of like working in the decimal version, it's going to be easier to stay in the fraction. Okay, so that's a quick recap of how we find a scale factor when we're looking at lengths, but we're not really looking at that because that's more of a grade 5 topic. We've taken that as assumed knowledge, and actually what we want to do is build on that and see what it looks like on the higher GCSE when you could be getting questions related to area and volume as well. So we're going to build some understanding before we dive into some questions. So I know that if I've got the length, let's say I've got this length here and this length here, I'm going to call this length 1 and this length 2. I know that this is going to have a scale factor of 2. 1 times 2 is 2. So that's my length. That's just what we've been talking about. Now I can turn a length into an area by obviously adding a second dimension. If I say that this square is 1 by 1, and I say this one is 2 by 2, then I've got an area on the first one of 1 and an area of the second one of 4. And I'm going to come back to that in a minute. If I do the exact same thing now and build this 1 by 1 into a cube, so I've got to add on, and I've got 1 by 1 by 1. And I do the same here with the bigger one and call those 2 by 2 by 2. Then my volume is 1. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. Okay. Now there is something really significant happening in our area and our volume and the way that it links to this. Okay, there is a scale factor that takes me from 1 to 4. And I naturally want to say, yeah, times by 4, scale factor of 4. And here I would naturally want to say it's times by 8. Okay, but I need to be able to problem solve between these. So I need to make a link to the original scale factor. The original scale factor is 2. I can use 2 to help me make 4. 2 to the power of 2 helps me make 4. So I now no longer need to be thinking of it as times by 4. I can now be thinking of it as times by 2 to the 2. Okay. The same thing is happening with this 8. I can make 8 by doing 2 cubed. So I now no longer need to think of this as times by 8. I can think of this as a scale factor of 2 to the 3, or 2 cubed. So my scale factor of 2 for the length is used throughout, except I've got a power 2 when it's area and a power 3 when it's volume, which is really easy to remember, because when we work in area, okay, if to say we were working in unit centimeters, the answer is centimeter squared. So this has just become scale factor squared for area, scale factor cubed for volume. So the key, if you like, for this is if you've got a question, oops, can't write in my light. If you've got a question about length, you're going to use the scale factor. If you've got a question about area, you are going to use the scale factor squared. And if you've got a question about volume, you're going to use the scale factor cubed. And that's the knowledge that you need to obviously get into your brain. So when you read the word similar, it triggers that, literally. So what I would recommend that you get into the habit of doing is the minute you read similar, you write the key, okay? Or read similar, read they're talking about area, and straight away write SF to the power of 2, okay? Do something, make that word similar trigger this. That's the goal. If you can do that, then you're going to find this topic actually really not that bad at all, okay? So that's the understanding as to why it's scale factor squared and scale factor cubed. Now we're going to get into some actual problems so that we can see how we apply it, how we use it. Okay, so let's have a look. So we've got 2 triangles, A and B. One is smaller than the other. We need to work out the base of A. So this is the bit that they want us to find. They've given us the area, haven't they? That's my fact. They've given me the area. Now I know that it's always the smaller shape times by the scale factor to equal the bigger shape, all right? But this one is area. So it's really important that I remember to put that power 2 on the SF. Now the area of the smaller shape is 10. 10 times a number I don't know squared is going to equal 250. I'm going to rearrange to get that scale factor on its own, that number I don't know. You could change it to N or X or a single letter, but I really like keeping it as SF because then I never lose sight of what I'm actually doing. I'm trying to find the scale factor. So I'm going to divide through by 10. Okay, I've now got my scale factor, my number I don't know, squared, and 250 divided by 10 is 25. Square root of 25, and my scale factor is 5. So I've used the information that they've given me and what I understand about scale factor to take me all the way down and find the original scale factor for length. Now that I've got the scale factor for length, I can work out what's happening here. So I know that it's the smaller times by the scale factor equaling the bigger. I don't know the smaller. When I times it by 5, it's going to give me 12.25. If I want to know what S is, then I've got to get it on its own. So we take this and we divide it through by 5. And I now know the missing side is equal to 2.5 centimeters. Okay. That is it. Every single question, no matter how it's worded, no matter whether it's area or volume, kind of works in the same way. I would really recommend writing this out every time so that you've got your 2 if it's area, 3 if it's volume, and it just kind of steps you through after that, telling you what to do. All right, we're going to try another question. Okay, so let's have a look at this one. Ooh, get it so we can see it. And clean this off so it doesn't distract us. Okay, so we've got a triangle, has a perimeter of 12 centimeters and an area of 6 centimeters. It is enlarged by scale factor 3. So they've told me basically that I have, and what you could do is you could start getting a sketch of it. A triangle has a perimeter of 12 and an area of 6. So I've got this triangle, let's call it A. It's got a perimeter of 12 and an area of 6. It says it is enlarged by scale factor 3. So let's say I've got B, and I know that to get from A to B, there is a scale factor of 3. So what I'm doing is I'm taking all the worded information, which can be really hard to follow, and I'm starting to put a picture to it. I'm modeling, getting a diagram, and getting a proper mathematical feel for this question. Whenever you are faced with worded questions, this is absolutely the best approach to getting some structure and some organization to the question. We're being asked what is the perimeter and area of the new triangle. Okay, so let's start with the perimeter. The perimeter is just a length, isn't it? We add all the edges. Imagine if I unfolded the edges, it would open out into one straight long line. It really is nothing more than length. So if the perimeter is 12 on the small, okay, so it's going to be small times scale factor equals big. If the perimeter is 12, then 12 is going in here. The scale factor we know is 3. So the perimeter is 36 centimeters for the bigger one. Then we look at the area, okay? So we've got small times, this is an area question, so scale factor squared will equal the B. The small is 6. The scale factor is 3 squared, which is technically 9. And 6 times 9 is 54, and this time it's centimeters squared. Okay, so that one, they've obviously got to come up with ways of trying to make this tricky. Now, when we're first learning it, we're a bit like, well, you know, don't really need it any harder, thanks. But let's see what they're going to do to us, all right, early on, and then we've got nothing to fear, nothing to fear. Wordy question, draw a picture. That is the advice. Okay, what I want you to do with this one is actually pause and have a go. Just stop. Think about what you've done so far, use the notes that you've made, and have a go at this question. Press play when you are ready. Okay, so we've got to work out the area of A. I'm not going to be able to do that unless I've got the scale factor. I am fortunate enough to have the match. I've got 2 on this edge, 5 on this edge. Well, these edges are equal because they're rectangles, so they absolutely do pair up. So my small times the scale factor equaling big. You don't have to write this out. I'm just doing it a few times so that we can see it's the same thing happening every time. So it's 2 times the scale factor equaling 5. Get rid of that times by 2. And I've got scale factor equaling 5 over 2. I could say that that is 2.5 if I wanted to work in a decimal, which might be nice. We'll pop it in because it's a nice simple decimal, isn't it? Okay. So now I can go to the area. All right. The small times by the scale factor squared will equal the big. I don't know the small, okay? I know the scale factor is 2.5 squared, and I know B has an area of 125 centimeters squared. So all I'm doing at that stage is just taking the information from the diagram and I'm popping it into the correct position. What I've got is where I put things, and what I haven't got, I have to leave as the letter that I've written down. So I'm using the S for small, okay? I could be using A and B, okay? It doesn't matter. You do what feels right to you. So now I know that I want to work out what the small is. So get rid of that times, it'll land as a divide on this side. And I've got S equaling 20, and that's 20 centimeters squared, of course. Okay, so hopefully that went well, fingers crossed. Got plenty more to practice together. Okay, I think we finished on that page. So on to this page. I want you to do exactly the same thing, please. I want you to just, oh, you can't quite see it all, can you? Let me just bring that down. That wasn't very well planned. There you go. Now you can see it. Now that might feel a bit scary because of the ratio that suddenly appeared. Ratio's got a bad habit of doing this. Again, don't wait just to be shown. Have a go. It's wordy. Draw a diagram. Try and use as much knowledge on this topic that you've got so far, and then obviously come back and see how it is done when you're ready. Okay. So squares A and B have sides in the ratio 2:3. So I'm just going to draw myself a little old square here, a bigger square here. They've got a ratio of 2:3. Okay. Square A, however, has a side of 8 centimeters. So let's label those up, A and B. So for my A side, I can now put in that the actual side is 8. So the ratio is 2:3. The actual size is 8. So I'm going to pop 8 there. To get from 2 to 8, I had to times by 4. So I'll do the same this side, times by 4. And that will give me a 12. So I now know that the edge of A is 8. And the edge of B, let's mark it on, that one's 8, that one is 12. Okay. It says find the area of B. Well, I don't have to do anything more fancy now than doing 12 times 12. It's a square. I know the edge is 12. So 12 times 12 is equal to 144. And of course, it's area, so it's centimeters squared. It then says find the ratio of the area of A to the area of B. So with this one, I'm going to find the area of A, which is 8 times 8, which is 64. We set this up, 64 dot dot 144, and then that will cancel all the way 4 to 9. So we'd always put it in our simplest. If this is a really good tip if you're not doing this type of thing already. If you put a ratio, so I had 64 dot dot 144 into the calculator as a fraction, 64 over 144, and press equals, that cancelled fraction is the same as my cancelled ratio. Saves me a lot of trouble and a lot of bother. So there wasn't a massive amount of scale factor with that type of question, was there? Okay, and you may have approached it slightly differently, which is fine. When we're problem solving with maths, we often find there's more than one way to do it. As long as your method is backed up with evidence to the answer, you're going to get all your marks anyway. All right, let's have a little look at this one. Okay, so find the dimensions of a rectangle B. Okay, so what I want you to do is I want you to pause Have a think about this question, have a go at this question, and then hit play when you're ready. Okay, so the first problem that really stands out here is I don't have an automatic pairing given to me. I've got no sides, so I can't match the 5 or the 3 to anything at all. And I've got no area here, which means I can't match that to that. But this question's been given to me, must mean it's doable. So I've got to really think, okay, what can I do? I can find the area of this shape actually really easily because I do have the dimensions. So that would be my starting point. So the area of the small one is 3 times 5, which is 15. Once I've got that, I then know that the small times by scale factor squared is equaling the big. So that's going to give me 15 times scale factor squared equaling 540. We're going to be dividing through by that 15, which is going to give me scale factor 2 equaling 36. Square root that 36, and I've got that my scale factor is 6. Okay, once I know my scale factor, I can then work out the dimensions. Okay, I'm going to be taking the 5, timesing by 6, and I've got 30 here. 3 times it by 6, I've got 18 here. I can check that in my calculator to make sure nothing's gone horribly wrong. It gives me 540. So all is good. So the dimensions are 18 and 30 centimeters. Okay. All right, here is the next question. Hopefully we're starting to feel a little bit more natural with this now, setting things up, writing things down. Okay, you're going to hit pause and press play. This one isn't too tricky at all. Okay. So this one might feel tricky just because it's volume, but it really isn't. It's been set up in a way that's going to make things really, really simple. I don't even need to set up the small times scale factor equals big, because just looking at these two numbers, I can clearly see that my scale factor is 3. It's a really easy one to not require anything more than that. So I've got my scale factor is 3. Now, my small times by scale factor cubed. We are now working in 3D shapes. So I've got my little 3 on the scale factor. So small times scale factor of 3, scale factor cubed is equal to big. I know the small is 80. I know the scale factor is 3, so that's going to be 3 cubed. And when I put that in my calculator, okay, which is basically 80 times 27, I get 2,160 centimeters cubed. And if you got that right, well done. It really was just making sure you put the right power on the scale factor for that one. Okay, next question. Again, I want you to hit pause, have a go, and press play when you're ready. Okay, so this is asking us, is A a cube? And you have to explain your answer. So you can't just say yes, because it looks like it. So the first thing we can do is we can actually work out the volume of the cube, okay? And the reason that we're working in volume is because we were given some information about the volume of this one here, okay? So I'm going to just say, if this is a cube, all the edges would be the same, and I would be doing 1.2 times 1.2 times 1.2. That would give me 1.728. So when I finish my similarity work, if it matches that number, it's a cube. And if it doesn't match that number, then it isn't a cube. So now I'm going to go back to what I know with the similarity. So I know that the small times the scale factor is going to equal the big. I've got 1.2 as the length, times by the scale factor, which is the number I don't know, is going to equal 12. So I'm going to divide through by my 1.2, and I'm going to see that my scale factor is 10. Okay, so my scale factor is 10. I then look at, obviously, the next step with the volume. So I've got my small times by scale factor cubed equaling big. So I don't know the small. I'm timesing it through by 10 cubed, and that's going to equal 3,600. I'm going to obviously divide through by 10 cubed, and the volume of the small comes out at 3.6 centimeters squared. So the answer that I'm getting when I'm using similarity to help me solve this problem is that the volume is this. So it's not a cube. If it was a cube, it's going to equal 1.728. So it's not a cube. It means that these dimensions here and here are not 1.2. One of them might be, but they're not, definitely not all 1.2. They must take different values in order to create the 3.6. All right. Hopefully that went well. I think the other thing to remember with this type of thing as well is if you're stuck, then all you can do is just try stuff you know. And it can be really surprising just how close you are to getting full marks when you do that. Similarity doesn't really change. And like I said, I know I haven't written the word down every time for these examples, and we're making that assumption that they're similar, but you won't make that assumption in the exam. It will say similar, and then this process is going to happen. All right, so over to you. There is another question. Press play when you are ready. Okay, so 6 and 10 are connected in this question. So small times scale factor equals big. 6 times scale factor equals 10. Divide through by the 6. And that's going to be my scale factor, which I'm going to keep in fraction form there, okay? The volume, I know the volume of the big, but I'm going to write it out. I'm going to do it up here. So I've got small times by 10 over 6 cubed, because it's volume, is going to equal the big, okay? I know that the big, because I started off by not writing scale factor cubed, I might as well go straight into the numerical. We know that that's going to equal this. So the small is going to equal 564 divided by this number, 10 over 6 cubed. And that is going to give me a final answer of 121.824 centimeters cubed. If the question's asking you to round in a certain way, then you must always go back and check that. It's unlikely that you would write an answer that long. You would probably be asked 3 sig fig or 1 decimal place or something like that. All right. If that one went well, then excellent. Okay, so have a go at that question, and when you're ready, hit play. All right, so let's have a little look at this question. So we obviously have the surface area. Now, this is the first time we've used the word surface area, but ultimately it is just an area question, and we mustn't start overcomplicating it by thinking, oh, well, that's all the different surfaces, and that's I've got to find them all. You don't. It's just total surface area, total surface area. They all scale up in the same way. So we've got to work out the surface area of B, and we've got to this time round to 3 significant figures. So first step is obviously finding my scale factor. So I've got small times by scale factor equaling big. My small is 2.25. Times that by my scale factor, and it gets me 18. So my scale factor is 18 divided by 2.25, which is a nice simple number, 8. So that's good. Now we're going to be looking at area. So it's the scale factor squared. So small times scale factor squared equals big. Small is what I don't know. I know that it's 8 squared now, equaling 508. So I'm going to divide through by my 8 squared, or my 64 if you've expanded that. That's going to give you 7.9375. 3 sig figs, that's when you just count the first 3 significant digits, which are those there. The 7 is going to get cut, and the 5, they're gone. But before they disappear, we've got to allow for the fact that that 7 is going to round that 3. So my final answer is 7.94 centimeters squared. Okay, so I hope that is coming together now quite naturally. You're now going to have a go. So you've got a set of questions. Let's get them big enough, hopefully, for you to read. In fact, if we get rid of that target mass at the top, that will help. There you go. Okay, so those are your questions. Obviously, I will forward on, and you can rewind forward, etc., and mark as you go. And then I will see you next session.